Hello everybody. Today we will continue our topic problem solving using dimensional analysis or formulas. I will show you some problems and their solution ways. Let's see the first problem. Okay, so let's see what we have. Let's start with the given data. We have here two solutions of potassium hydroxide. Let's write it like solution A and solution B. Two solutions. What is the data? What are the given data? So we know the mass percent of solution A is 18%. Its density is 1.20 gram per milliliter. And volume is given 65 milliliters. For the solution B, we have omega, that is 27%. Percent by weight is 27. Density was given 1.30 gram per milliliter, and its volume is given 80 milliliters. Moreover, we know the molar mass and what is required to find the final concentration of potassium hydroxide mole per liter and the mass of potassium hydroxide in the final solution. So let's start with the solution A. Let's consider that we have 100 gram of solution. So let's find 18 gram of potassium hydroxide multiplied by, so the molar mass we said is 56.11 gram per mole. It means in 1 mole, we have 56.11 gram per mole. The answer will be, then what we do next, the volume is given 65 milliliters. Density is also given. So what we do, 65 milliliters of the solution is multiplied by its density, 1.20 gram in 1 milliliter, and the answer will be so. After that, what we can do, we say that this number of moles of potassium hydroxide was in 100 gram of solution. Mole in 100 gram of solution, right? Because 18% means 18 gram in 100 grams. And now we found, let's divide the number of moles that we found, this number, this one, divide it by 100 gram, because we considered like mole per gram. Yes, in 100 gram we have this amount of mole, and let's multiply it by the real mass of the solution, that is 78, and let's find the answer. 0.25 gram of solution. We found the mass of the solution here. What we do next, that was for A, for solution A. Let's calculate it for solution B. For solution B, we said omega was 27%. Let's consider that we have 100 gram of solution, and then there will be 27 gram of potassium hydroxide, 27 gram of potassium hydroxide. You multiply it by The molar mass, as we said, is 56.11 gram in 1 mole. Mole in 100 gram. But indeed, it's not 100 gram. Let's find. Let's take what is the volume? The next step, volume of 80 milliliters. Let's multiply 80 milliliters by its density to find the mass of solution. So we have volume, we have mass. So we said that in 100 grams, we found that in 100 grams of solution, we have this number. But indeed, we don't have 100 grams of solution, we have 104 grams of solution. So let's find how much potassium hydroxide we have in 104 grams of the solution. That's what we do. The number of mole that we found, divide by 100, it's mole of potassium hydroxide, divide by 100 grams of solution, and we multiplied by the real mass, that is 104 gram, 0.5 mole of potassium hydroxide. Now let's find the total number of moles of potassium hydroxide. So total number of moles is number of moles in A plus number of moles in B. Let's find it. And total will be Na So there was a mistake, it was not gram mole. So let's use this number here. Plus the number of moles for B is 0.5. The answer will be 0.750 mole, the total number of moles. What we do on the next step, we have to find the total volume, the total volume of A plus volume of B. In the condition, it was given that A is 65 milliliters. So 65 plus B was 80 milliliters. The answer is the total volume is found in the final solution. So we can now find the concentration that is found by the formula N divided by V. So we take the total number of moles, 0.750 mole, divided by concentration molarity must be mole divided by liter. We have 145 milliliters, so we convert it to liters and write here 0.145 liters, and the answer will be 5.17 molarity, or mole per liter. Then the second question was to find the mass of potassium hydroxide. We found its concentration. The question was to find its concentration. The second one was to find the mass So let's calculate the mass now. We know number of moles, so we can use the formula of moles. M divided by molar mass. Hence, mass will be equal number of moles multiplied by molar mass. Mass equals, so we found number of moles, 0.75, total number of moles multiplied, and the molar mass was given at 56.11. The answer will be 42.1 gram. Well, since my screen is small and I cannot write everything on one screen, I have to always move the screen. For this reason, I recommend you to do this together with me. While you are watching this video, you can either take a notebook or take a piece of paper where you will write it while looking. Write all the data. In this case, all the data will be in front of your eyes, and it will be easier for you to follow it without moving the screen every time. Now let's look at another task. The reaction is given already in the condition of the exercise. For this reason, I will not write it again in order to avoid time wasting. Let's now write the given data. So we have to calculate the volume of calcium chloride. The concentration of calcium chloride is given 0.8 molarity. C of calcium chloride is 0.8 m molarity, or mole per liter. It means 0.8 mole per liter. Okay. Then, what we have to do? We have to calculate its volume. The volume is not given. The volume must be in liters. We must calculate it in liters. Now, what is given? This concentration of another sodium sulfate solution, C2 for sodium sulfate, is 0.5 molarity, or as you know, it's 0.5 mole divided by liter. And its volume is also given, that is 200 milliliters. And we also have to calculate the mass of calcium sulfate. So we have here two questions: to find the calcium sulfate and to find the volume of calcium chloride. Well, let's now do this solution. Move to the solution part. Okay, let's see what we have and how we can use it. If you look at the reaction, pay attention to the coefficient. The calcium chloride, sodium sulfate, and calcium sulfate all have coefficients 1, while sodium chloride has the coefficient 2. If we divide the number of moles by their stoichiometric coefficients, we will find the stoichiometric conditions. Number of moles of calcium chloride divided by 1 equals number of moles of sodium sulfate divided by 1 equals number of moles of calcium sulfate divided by 1 equals number of moles of sodium chloride divided by 2. So this condition, they are in stoichiometric balance. Okay, now what we can do? We need to find the volume, we need to find the mass. We have concentration. We know that we have C in the task. We can see that we have the molar concentration. Indeed, C equals N divided by V. N equals M divided by M. These are the formula that you have to know. You need to find, in one case you need to find the concentration, in the second question you need to find the mass. For both of these cases you need to find the number of moles. Well, that's why, so now I'm reading this formula, we understood that we have to find the number of moles. Let's find now it. We have C and V for the second solution for sodium sulfate. So we can find the number of moles of sodium sulfate. We can find the number of moles of sodium sulfate. It will be C2 by V2. Concentration is given, volume is given. So concentration is 0.5 mole per liter. Multiplied by volume is 200 milliliters. Again, pay attention, here we have liters, here we have milliliters. So we have to convert milliliters into liters. So we will write like 0.2 liters. So liter and liter are cancelled. The answer is 0.1 mole. That is for sodium sulfate. So let's go step by step. We need to find the volume of calcium chloride. So we need to find the number of moles of calcium chloride. And we see that calcium chloride is with sodium chloride is 1 to 1. So number of moles of calcium chloride equals to the number of moles of sodium SO4. Number of moles of calcium chloride equal the number of moles of sodium sulfate. It will be 0.1 mole as well. They are equal. So we know this formula as we wrote before. C equals N divided by V. So in order to find volume, divide number of moles by its concentration. We can say number of moles is 0.1 mole divided the concentration 0.8 mole per liter the answer will be 0.125 mole, and molar cancel, liter remains. We found the volume. Now we need to find the mass of calcium SO4. For finding the mass, we can use again the number of moles and its molar mass. Molar mass of calcium sulfate is 136.15 gram per mole. Number of moles equals mass divided by molar mass. So mass will be number of moles multiplied by molar mass. Let's see the number of moles of calcium sulfate. Number of moles of calcium sulfate is also 0.1. They all are equal. The number of moles will be again 0.1 multiplied by the molar mass, 136.15. The answer will be 13.62 grams.